All right, guys, another video about inverses. In this case, I was given a line. I wasn't specifically given points, but and I'm going to zoom in. I'm going to pick out the lattice points. And by that, I mean points that have an integer as both the X and the Y coordinates, or we're on this grid where the line intersects the grid right at a corner point, or what I call lattice point. So, that first one there is at -6,3. So I'm just going to kind of over here plot the points. -6,3 is one of them. That looks like -2,2. And just pardon me as I kind of zoom in and zoom out. 2,1, 6,0 is the x-intercept, and yeah, I guess that's it. Yeah, 4 points is enough, right? And then the inverse, of course, actually, to be honest, it's a line, so 2 points is really all we need. But I did it a little bit overboard. I did 4 here. Now the inverse, we'll pick a color. Let's do something fun. How about this, like orangish color? Okay. Hey, guys, the order pairs, we just reverse them. 3, -6, 2, -2, 1, 2, 0, 6. And I'm just going to plot those points. All right. 3, -6 would be, of course, down here. I'll put a dot. 2, -2 be about right there. 1, 2 would be here, and 0, 6 is up here. And then I'm going to connect them, and it better be linear. It better be a line, because if the original function is a line, then the inverse also has to be a line. So let's just make sure they line up. You'll know right away with a ruler. I could tell right away with this. Essentially this Apple Pen is a straight edge, and I'll just keep it going in this direction. So there's my line. So if that's F, this is what we would call F inverse. And I guess we could put the X there as well. And finally, you could see I got that dashed pink line. That's, of course, that famous line, Y equal X. That's the symmetry line. And again, tilt your head sideways. You can clearly see that it's a line of symmetry. Okay. Yeah. Hey, let's do one where we have to actually graph a function. So we're given an equation. We'll start easy enough. We'll graph the line 5x. You got a lot of options here to graph this, right? If you look at it, this is really y equals 5x. You don't even have a y-intercept, 0, right? So that's the slope. There. Let's go back to algebra 1. The slope is 5/1. And of course, the y-intercept is 0, which means what? I hit 0, 0. And every time I go 1 to the right, I go 5 up. And 1 to the right, I go 5 up. Of course, 1 to the left would be 5 down, and 1 to the left would be 5 down. If I connect the dots, I have this thing in purple. You can see the slope is 5, which is pretty steep. And the y-intercept is 0, so it hits the origin. And now I want to find the inverse function. Okay, so I'll tell you what, I'm going to give myself a little room. I'm going to kind of minimize that, bring it over here, and I'll go through the steps to find the inverse. The first thing, f of x, I call it y, right? I kind of get rid of f of x. We know f of x is equal to y. Fx is just kind of a fancy symbol we use for that. And then when I do the inverse, I'm reversing the x's and the y's. So everywhere I have a y, I put an x. Everywhere I have an x, I put a y. And just like your whole math career, we want to get y by itself. So you say, hey, how do you get rid of a 5? You divide by 5, or specifically, you're going to multiply both sides by 1/5. So I'll put a 1/5 here and a 1/5 here. So that gets y by itself. I'm going to kind of flip it around, but sorry, this gives me y by itself, and y equals 1/5 of x. All I did was I took this y and I kind of switched sides with it. So of course, what does that mean? That's my slope. And of course, I still have a y-intercept of 0. By the way, you could go one extra step and call this F inverse of X equals 1/5 X. That would actually be what the inverse looks like. But if I graphed it, I don't know, let's pick a color. I guess I'll go green again, right? Let's highlight this in green. If I was to graph this guy, this inverse, I would hit the origin and I'd go 5 to the right and 1 up, right? That's the difference, 5 to the right and 1 up. So if you follow the pattern this way, there I go. And you could actually take some ordered pairs and just reverse them if you'd like. You know, that's your other option. Take the ordered pairs from the purple graph, flip them around, you'll get the green graph. And then your fail-safe, your ultimate check with anything with graphing inverses, if you take a peek at the line y equal x, you ought to have symmetry in that line. And it's pretty clear to me that we do. So we graph this correctly. Okay, guys, good luck with inverses, all right? Don't forget, we're always an email away. All right, take care.